Hello everyone. Let's revise the final revision to pass your checkpoint exam. Good luck for your physics exam tomorrow, inshallah. Let's start with the main concepts you need to understand. How can we measure the different physical quantity, which is the basic quantity, like the length and the mass and the time. How can we measure the length? We can measure the length by using the ruler or by using the measuring tape. The ruler is used to measure the short lengths, just like the pencil, like the pen, like a small spoon, a short spoon, a small pen. But the measuring tape, it is the tool that used to measure the longer lengths. And the unit of the length is centimeter or meter. And to define what is meant by the mass, it is the amount of matter in an object. And to measure the unit of mass, it is the gram or kilogram. The mass tools or the mass instrument used to measure the mass, it is the balance, whatever the kind of the balance you use, sensitive balance or top band balance or digital or beam balance. Of course, you can use the sensitive or digital balance for very small grams for objects, for the smaller objects. The third basic quantity, the third physical quantity from the basic quantity you need to know, it is the time, and the time, it is the measured between the two intervals or between two events. It is the interval between or the difference between the two events happen. How can we measure the time? The time can be measured by the second or by the minute. And the tools or instruments used to measure the time, it is the stop clock or stopwatch. As we can see, the mass and the time and the length, it is the three basic quantity or three basic quantities, which can be measured directly from the apparatus or from the tools without any difficult or complicated measurements. Let's revise سريعا the unit conversions to measure, to convert between a smaller unit to a larger unit. You need to multiply, and if you need to convert from the smaller to the larger unit, you should divide the unit. Like, for example, if you need to convert from the meter to centimeter, you need to multiply times 100, or from centimeter to millimeter, you need to multiply by 10. Just for remember, if you have a lot of readings in your investigation, you should calculate the average to compare between the results. The first lesson in our topics, in our syllabus, is topic 1, which is discuss and study the meaning of density. The density, it's a derived quantity, which represent the ratio between the mass over volume. To define the meaning of the density, so you need to understand what is the relation between the mass and the density, and between the volume and density. If you have two objects, the higher the mass, the greater the density, which means it's the heavier object. And if you have lighter object, so it has lower mass, so of course it will have a lower density and it become lighter. And the relation between the mass and density is directly proportional, which is mean the greater the mass, the greater the density. But the relation between the density and the volume is inverse relation, which is mean the greater the volume, the slower, the lower or the less the density. And of course, the smaller the volume, that means the higher the density. As a problem to understand and to practice how can we calculate the density of any object, you need to calculate or to measure first the mass and first volume, and then you will divide the mass over the volume, so you will get the density of the object. Of course, if you draw a graph between the density and between the volume, the relation between the mass and volume is direct relation, which is mean the greater the mass or the greater the volume, as you as if you draw a relation between the mass and volume, you will get a straight line passing to the origin, and the gradient of this line will be the density. And the density is the difference in masses over the difference in volume. Okay. The density formula simply you can extract or you can calculate, and you remember the unit of the density just immediately if you remember the relation between them as a formula or as a rule. As the density equal the mass over the volume, so the unit of the mass is kilogram and the unit of the volume is meter cube, so that the density is given in the unit kilogram per meter cube. Okay, we can use the formula triangle, which is called the magic triangle for me. It's a magic because you can find the three quantities from the main or from the same, sorry, the same triangle, which is a density equal the mass over the volume. So if we need to calculate the mass, we just hide the mass and multiply the two quantities away from the mass. So it will be density over the times the volume, and density will be the mass over the volume. Of course, finally, you can find the volume from the same magic triangle. Just a quick revision about the density. Of course, how can we calculate or describe if you have a question to understand, or if you're asking in your exam about describe how can you measure the density of regular objects. So in your answer, you should write how can you measure the mass, and write you can measure the mass of the object by using the balance. This is the first mark, and the second mark you should refer about how can you calculate the volume of this object. Because of the object is regular, so it's simple to measure its length and width and height and then multiply them together, so you will get finally the volume of this object. So congratulations, guys. So you have the mass and you have the volume. It's simple to calculate the density of this cuboid or of this object. As a quick practice about this this part of your syllabus. If you have a solid object and this solid object has a mass, for example, 180 grams, and the volume of this object is equal 45 cubic centimeters, so simply you can multiply, so you can divide mass over the volume, so you will get the density of this cube. But be careful, wait, how can we measure the density of the irregular objects? We cannot use the ruler to measure its volume. So if you have a regular object, just like a stone or a rock, you can measure the volume by using method called the displacement method. So if you have a question in your exam to describe or explain how can you measure the volume on the mass of the irregular object, it's simple. The irregular object can be measured directly from, it can be extracted directly from the balance by place the object on a balance and just record the number you have on the mass balance, on a balance to measure the mass of this irregular object. But what about the volume? If you have a question to ask about, which is asking you about how can you find or calculate the volume of a regular shape, you can use the displacement method. The displacement method is place or pour a known volume of a measuring cylinder and record this volume is the V1, and then gently or use a thread or gently immersed or pour or put or place or gently immersed or submerge this irregular object in the measuring cylinder and record the new volume, which is V2, and then finally subtract the new volume V2 minus the original volume, which is the volume of the known volume of measuring cylinder. So now you have the volume of the irregular rock. Example, you can divide the mass over the volume, so you can calculate the density of the irregular object. Here you have a table which gives the different amounts or different magnitudes, different values of density for different materials like the ice, wood, polythene, and glass and steel, which is solid material, and the liquid materials and the gases materials. Okay, the different elements with different states of matter give different amounts of density. That's because the density of the solid, of course, is greater than the density of liquid, and of course, the density of gas is the least one because the particles of the gas are organized irregular shape, and the distance between the particles in the gas is furthest apart from each other. As a worked example to remember how can we describe the density of ethanol, for example, which is liquid. So you need to use the same method of displacement method, which use the displacement method with the measuring cylinder. So you need to calculate the volume of ethanol directly from the measuring cylinder. But what it is a method. How can you measure the mass of ethanol because it's a liquid? So first of all, you need to use the imbalance to measure an empty measuring cylinder first and record the number that you got from the balance, which is M1, and then calculate and then pour, the ethanol in the cylinder and subtract the difference in mass, which is represent the mass of the ethanol. And simply you can get or can read the volume from the measuring cylinder, which is represent the volume of ethanol. So now you have the mass of the ethanol and the volume, so you can get and calculate the density of the liquid by the same way. The second lesson in your topic, in your syllabus, is topic 2, which is the energy. The energy, in fact, can be defined as ability to do work. So if you can do a simple work, so you can push a door in front of you, or you can push a desk along a ground, or you can pull a cupboard or whatever. So you can do a work which is mean you have energy. You have ability to do a work, so you have energy, okay? And important part in your syllabus, which is the law of conservation of energy. A scientist called James Joule, which is talking and states an important rule which discuss the relation between the input and the output energy and the energy transformation. Joule said that, the conservation law of energy states what? State that energy is neither created and nor destroyed, but it can change from one form to another form. Okay, here you have a lot of examples in your diagrams or in your photo. As you see, this man is climbing to the cliff, and he has lower kinetic energy in the bottom of the cliff. Once he starts to climbing to the cliff, so its potential energy start to decrease and the kinetic energy start to increase until he reached to the top of the mountain, which is represent the maximum value of potential energy until return back to the bottom again, which is mean maximum gravitational potential energy and decreasing in kinetic energy. Same as for the pendulum or swinging a ball or a pendulum. In fact, the energy can be classified mainly in two main basics forms, which is potential energy and kinetic energy. The energy can be classified الحقيقة into main sections, which is stored energy. Energy could be stored or could be mobile or kinetic or moved. The first one, it is the stored energy. It's a gravitational potential energy or chemical potential energy or nuclear potential energy or elastic potential energy. So the energy could be stored in an object. It could be conserved, sorry, يعني is stored in the object, doesn't transfer لغاية دلوقتي unless حصل movement or حصل motion. So the kinetic energy here, it is represent any kind of energy that causes as a result of the moving of particles, like the mechanical waves or the mechanical energy or thermal energy, heat energy, sound energy, light energy, electrical energy. All of them is represent movement or motion. Okay, so you can classify the energy as energy transfer or energy stored. Here we have important part in your syllabus, which is new in your checkpoint exams. Please concentrate in this part because it's very important. The difference between the heat and temperature. There is a big difference between the heat and temperature, but what is the difference between them? Most of the students had a lot of misconception about these two physical quantities. الحقيقة إنه الheat, it's a form of energy which can measured by الجول. Its unit is joule. It's just a form of energy, represent gain or lose energy. Warmer or colder the object is. But the temperature is just a reference, it's just a measurement to measure the average kinetic energy or average thermal energy or internal energy represented or the object has. Okay, the temperature in fact can be give you information about the direction of thermal energy. The energy always transfer from the hotter object to the colder object, not the opposite. And the temperature measured in the Kelvin, which is SI units of the temperature. It's not by Kelvin, it's not the Celsius unit. The thermometer, it is the instrument, or this is the technique, the apparatus used to measure the temperature, which give you information about the reference of, it is represent the temperature. That mean how much energy you have, you lose or you gain. The heat is, again, is a form of energy and it can be measured in joule, and you have not, we don't have any direct techniques to determine the amount of heat. The Sankey diagram, it's a simple diagram which represents the energy transformation from the input energy to the output energy. As we said before, the conservation law of energy said that the energy neither created nor be destroyed, but it can change from one form to another form, which is mean if you have energy stored as a chemical potential energy, like in the space rocket, like in this rocket, the fuel, which is the main factor which give the rocket the reason to move. So the burning of fuel in presence of oxygen, which will make the rocket to move or to launch up. Okay, so the chemical potential energy which is stored inside the fuel and now transfer as a kinetic energy, which is the useful energy, because the useful energy for the rocket is the kinetic energy. And of course, some of gravitational potential energy and a lot of internal energy or thermal energy go to the surrounding as a wasted energy. To discuss or to consider any vehicle as a more efficient vehicle, you should have the more useful energy greater than the wasted energy. Another example about the Sankey diagram, which is the filament lamp. The filament lamp here we have a less efficient filament lamp because the input energy here is 100 joule and 85 joule go to the surrounding as a wasted energy. So this bulb or this lamp is not efficient at all because the useful energy is only 15 joule goes to the surrounding 85 joule, and the useful, which is the light, because we need the light, we need the filament lamp to light our rooms and our place. Okay, here we go. You have the main concept, which is very important. The thermal energy or the heat is transferred from the hotter or the warmer objects to the colder one and not the opposite. The energy transformation, how can we transfer energy through different objects? الحقيقة we have three main processes in which the energy could be transferred from one object to another. The first one is the conduction. The conduction, it is the transfer of the heat through a material by a direct contact. So it should be a direct contact between the particles, between the objects. If we don't have any direct contact between a pan, for example, and a table or oven, or between a fire or a Bunsen burner, for example, so the pan will not get hotter. That's because there is no direct contact between the particles. How the conduction occur? The conduction take care, obviously, in the particles of solids because the solid particles are arranged in a regular pattern in a regular lattice, which mean the particles of the solid vibrate in its own position backward and forward to the left and to the right, but without any transfer of the particles or the molecules itself. So how can the thermal energy transfer from the particle to another? As a result of the molecule vibration. The vibration transfer from the particles to another to adjacent one until it reaches the cold part of the object. The presence of the free electrons or the mobile electrons in the conductors that make or enable the metal to become more conductor for heat. That's why the metal is a good conductor and the insulator is a bad conductor due to the absence of free electrons in insulators and the presence of the free electrons or the mobile electrons or called delocalized electrons in the metal conductors. Here we have a zoom in inside a cross section of conductors, which represent if you heat a part from a metal or from a conductor, the particles gain more kinetic energy, so it starts to vibrate in its own position, and the thermal energy transfer to the adjacent particles until reach the cold parts of the metal and the electrons, of course, help in energy transformation. Here we have an investigation. It's just example to represent how we can consider uh, uh, we can predict which one is the more conductor elements. If you have a Bunsen burner and a tripod and you place the 3 or 4 rods, different materials, in a tripod, and then you fire the Bunsen burner or you turn it on, the first part from the rod start to gain heat energy, and so at the end of the rod you place or you stick a simple piece of wax in the different rods. At the end of each rod put a paper clips. Okay, so in this investigation, you should decide which one is the control variable and which one is the dependent variable, and finally, which one is the independent variable. Here we have the control variable, which is the variable you should keep it constant through the whole investigation to get more fair test. So you should use the same length of the rod, the same thickness of the rod, and the same distance between the rods and the Bunsen burner, of course. And of course, you should place the paper clip at the same distance from the Bunsen burner to get a fair test, okay, or to get more accurate results, and to avoid any source of error may get at the end of your investigation. As independent, you test the conductivity of different materials. You can you can deduce at the end of your investigation which conductor, which metal is the good conductors and which one is the least conductor. And I can predict, or I can put a hypothesis here, which is I can predict the metal rod which make the paper clip fall faster, so that mean it is the good conductors for ill heat. Here we have the last one, which is the dependent variable. The dependent variable, you need to measure the time taken to pull the paper clip from the rod. So you need to measure the temperature. It starts from the same initial temperature, by the way, not exposure the different rods to different materials. At the conclusion, I conclude that the metal rod that make the paper clip falls faster, this is represent the good conductors rod. Okay, and the second one is the convection, and the convection is the second process in which the energy can be transferred through the environment or through السيستم اللي عندي. Okay, if you have a heater which is placed in on the ground in your living room, for example, just you turn on your heater, the air surrounded on your room, the air particle that surrounded the heater gets hotter and gain more energy, so its temperature start to increases as well. Okay, and then when the temperature increases, so the volume of the particles start to expand and gets bigger, and expanding of the particles leads to decreasing in the density, which is mean a lighter object, so it can be easily raises up to the surrounding and leave its space empty. So it's replaced by the air-cooled particles in the room, which has lower volume and greater density. So it's higher density, so it's heavier. So it sinks in the room, replaced the hotter one, which leads to a convection current at the end of this process. This is experiment where investigation to investigate the how can you represent, or how can you understand more the convection current or the convection as a way of energy transfer. If you have a box and this box has two holes, and at the end, the top of the two holes just immersed two tubes. At the second one, put a candle in the bottom of this candle, in the bottom of the glass tube, and put a burner paper. You will notice that the paper will sinks down. It sinks down, not raising up. That's because the air particles raises up because it becomes lighter as it gains more energy, and the temperature as well increases. The last method of energy transfer, it is the radiation. And radiation, it is the last energy transfer method in your syllabus. The radiation is completely different from convection and conduction. That's because in the radiation, it doesn't need any need for particles, because the energy transfer by magnetic waves. So it moves in a vacuum with the speed of light without any need of particles, and it's faster way to conduct heat energy.